For the ready, set, go portion of lesson 2.2, the ready portion, we're going to be looking at a change of rate. So we want to be able to find a unit rate. We want to try to make things comparable and then compare. So for the first part, we have a short bungee cord stretching 6 inches when it's stretched by a 3-pound weight. So if I have a bungee cord here, yay, there's my bungee cord, and I have a 3-pound weight. It has been stretched 6 inches. So to represent that, we can say 6 inches for 3 pounds, of pull. 6 inches is 0.5 feet for 3 pounds of pull. So if we wanted to, and we're going to, we need to find a common unit of measure. And if you look at the other one, it's a 1 pound weight. So we can't just go however we want. We've got 1 pound weight, but it's 3 feet for the slinky. So we're going to keep things in terms of feet. If we divide this out, 0.5 divided by 3, we would get 0.166666 repeating. So we can say 0.17 feet for every 1 pound of pull. Now the second part, we have a slinky. Yay, slinky. And on the slinky, there is a 1 pound weight. And it's got 3 feet of stretch. So 3 feet for a 1 pound weight. We now have comparable units. We have feet, pounds. So we know that the slinky is the one that has the greatest rate of change in this example. For number 3, similar. We were going to try to create a comparable unit rate. So we have 25 gallons of gas in a 3-minute period of time. And if we divide this out, we end up getting 8.3 gallons for every 1 minute of pumping. Not too bad. The bathtub, on the other hand, has 40 gallons every 5 minutes. And when we divide that out, we get 8 gallons in 1 minute. Pretty good, but 8.3 gallons per minute is going to be flowing at a faster rate. That's why we're setting up these unit rates to be able to figure out how much is it happening in 1 minute or 1 pound or whatever it might be. For numbers 5 through 11, we're getting more practice with discrete and continuous models. So for number 5, freeway construction. And we're pouring concrete. The thing with concrete pouring over a freeway is it's a lot of concrete. And they are continuously running that machine. So what we can say is that this would be a continuous function, and that the machine is going to be pouring out, the concrete truck is going to be pouring out the same amount per second, per minute, per hour, whatever it is. So we know that this is an arithmetic relationship. It's going to be a linear model as we figure out how much concrete is being used. Number 7, the bricklayers for this construction company have been told you need to increase your production by 5% each day. So they're not coming back at 8 o'clock a.m. and then 9:30 a.m. and then 10:22 a.m. and then 1:44 p.m. and checking in on them. They're just saying at the end of every day, 5% more bricks. So because of that, that is a discrete model. And because it's 5% more, we're multiplying that and then adding it to what we had. We would consider this a geometric model. Number 9, City of Buenos Aires, adding 8% to its population every year. Now, 8% to its population, there may be kids being born every day, people moving in every day, but it's not this continuous flow of people. They are specific, discrete moments in time that people are coming into the city of Buenos Aires. So this can be considered, again, a discrete relationship, and 8% to its population means that it's also geometric. You're going to take that 8%, multiply 1.08 times whatever you had the year before. That should tell you what the population is going to be after. For number 11A, this is more of our traditional problem, where we have a beginning point and how it moves. So here, in a recursive setup, we are talking about a discrete model, okay, because we're talking about individual steps, and this would be considered arithmetic because we are adding 3. For B, we have individual points. Individual points means that we are talking about a discrete model. And because this is not going down in a line, but instead in an exponential decrease or decay, we call it that, geometric relationship. For 11C, 2 to the x tells me everything I should need to know. I know that it's geometric. And because I can plug any number in there, we know that this is continuous. For the go portion, we're going way back to 6th and 7th and 8th grade, being able to solve 2-step equations. So when we're doing this, first we need to remove our constant, and next we need to remove our coefficient. Again, for number 13, first we need to remove our constant, and then we remove our coefficient. There is no constant for number 15, so instead, we just focus on removing the coefficient. Again, no constant for number 17, so we just focus on removing the coefficient. And for number 19, same process. No constant, focus on the coefficient. And if you notice here, I'm multiplying by the inverse. Okay. Hopefully that helps. Please, please, please reach out if you have any questions.